All right, 2021, number 4, this is calculator inactive, it's the AB test. Let f be a continuous function defined on the closed interval from -4 to 6. The graph of f consisting of 4 line segments is shown above, so 1, 2, 3, 4 line segments. They tell you that just so you don't think maybe it's slightly curved and I can't tell, it's just piecewise, linear. Let g be the function defined by g of x equals the integral from 0 to x of f of t dt. And I would like to go ahead and point out that g is the integral of f. And so before I really get too far with this, and you don't have to start with this idea, but this is where my mind goes. If g of x is the integral from 0 to x f of t dt, then I can take the derivative of g, which of course will give me g prime, and the derivative of an integral, and so this is kind of what we used to call the second fundamental theorem of calculus. Different textbooks call it different things, but basically the x is going to go right here, and that just gives me f of x. Long story short, you're taking the derivative of an integral, and they undo each other. And we'll go one step further, so g double prime of x is equal to f prime of x. And that'll be really all we need to do. Do you have to do it now? No, but it's going to come in handy, trust me. So, part A, on what open intervals is the graph of g concave up? Stop right there. The graph of g is concave up. This is not the graph of g, this is the graph of f. So if I'm going to talk about the graph of g being concave up, I need the second derivative of g to be positive, so here goes. This did come in handy. Second derivative of g needs to be positive, so here goes for part A. What I need is for this, the second derivative of g, which is the first derivative of f, to be positive on some intervals. And so we're going to find out where it is. And it says give a reason for your answer. We'll deal with that in just a second. So here goes. The second derivative of g, which is the first derivative of f, is positive. Okay, if this is the graph of f, and I'm looking for where the derivative of f is positive, I'm looking for where this graph is increasing, which would be from -4 to -2. And then not here, but it will be here, so from 2 to 6. So this is true on the interval from -4 to -2 and 2 to 6. So have we answered the question? I really think so. I'm going to try to articulate it a little bit more clearly as we go. So on what open intervals, open by the way, parentheses, notice that, is the graph of g concave up? Give a reason for your answer. It's concave up for this reason. So, and therefore, g of x is concave up. Okay, now, there are some that will grade this and maybe find a little bit of fault with it. So I'm going to go a little bit further because I want to be as meticulous and articulate as possible without us getting too caught up in, oh, did I say this and what are they looking for? And we need to be cognizant of that. But I really want to represent what was shown. Let me clarify. They did not give us the graph of f prime. They gave us the graph of f. So this is valid. But it may not earn us points because they probably want to know that we are interpreting this correctly. So, good line of thinking, fantastic. But how do we know that this is where f prime is positive? I was looking for where this graph was increasing. I'm going to just keep expounding on this. It is on these intervals. It does not have to be worded like this. It is on these intervals that f of x is increasing. Okay, so while the first sentence is mathematically correct, I'm concerned it may not earn us points because they need to know that we're able to look at this graph and know what we're looking for. And this graph is the graph of f, and this graph of f would have a derivative that is positive where this graph is increasing. And that's what we've articulated. Okay, a little meticulous, but worth it. Here goes, part B. Let p be this function, and g of x times f of x. And then they want us to find p prime of 3. Well, before we find p prime of 3, let's go ahead and find p prime of x. And that would be the product rule. So we'll do this first. Start there. And then I want to find out what happens if I plug in a 3. So let's do that. P prime of 3 is g prime of 3 f of 3 plus g of 3 f prime of 3. And we're just going to figure this out as we go. So g prime of 3, well, g prime of 3 is f of 3. See, all this up here is going to come in so handy. F of 3 times f of 3. It's f of 3 squared. Not f of 3 squared, but f of 3 squared. All right. G of 3. Well, g of 3 is something that's going to take a little bit of work. G of 3 is going to be the integral from 0 to 3 f of t dt. So this is, let's think of it as accumulated area. The accumulated area from 0 to 3 on this graph is what we're dealing with here. We can go ahead and figure that out. The accumulated area from 0 to 3 on this graph is going to be, well, first of all, really easy because positive triangle, negative triangle of equal area. And so these two cancel each other out, so it's really the same as this from 2 to 3. And we can count this one. So let's not get all crazy and be like, well, it's a trapezoid with a, no, just, yeah, but 1, 2, 3.5 squares. 3.5. Don't make it harder than it is. 3.5. And then we're going to multiply by f prime of 3. Okay. F prime of 3 would be the slope of this graph at 3. The slope of this graph at 3 is rise 1, run 1. So 1. So times 1. And so we need f of 3. Back to the graph. F of 3 is negative 3. So we have negative 3 times negative 3 plus 3.5 times 1. And something about this feels a little bit off. Whoa, I am off. I'm off. Glad I caught it right now. All right, we're going to have 9. Here goes. Let's fix a mistake. Something felt wrong. This 3.5 is negative. Whoa, be careful. I said that to myself. This 1, 2, 3.5 was below the x-axis as we moved from left to right. So that should have been negative and negative. There we go. So 9 minus 3.5, which is going to give me 5.5. Okay. Part C, let's go to another piece of paper, is asking us to find the limit as x approaches 2 of g of x. Most of these, when you see it structured like this, you're going to run into a L'Hopital situation. I'm just saying. So don't just default there, but that is a good place for your mind to go. So let's see what happens if I plugged in a 2. So if I had the limit as x approaches 2 g of x, then I would really have g of 2, which would be the integral from 0 to 2 of the function, t dt. And we actually just talked about this. Going from 0 to 2 would cancel out the positive and the negative area. So this one is 0. So the numerator is 0. We're well on our way to L'Hopital. Limit as x approaches 2 of x squared minus 2x is going to give me 4 minus 4, which of course is 0. Feel free to skip a step there. So we're going to have a L'Hopital situation. So 0 divided by 0. Again, never say that something equals 0 over 0. That is mathematically incorrect. But this is going to be L'Hopital. Often in the scoring guideline, they'll call it L'Hospital for real, because they're essentially the same word in a different language. All right, so we're going to take the derivative of the numerator and denominator. So here we go. The limit as x approaches 2, g prime in the numerator, and 2x minus 2 in the denominator. So we're already out of L'Hopital land, because if you plug in a 2 in the denominator, you won't have a 0. So that's going to give us g prime of 2 over 2 times 2 minus 2, so 2. And these 2's cancel. I'm kidding. Don't you dare cancel those 2's. That was a joke. That wasn't funny. I ought not joke about incorrect mathematics. So g prime of 2. Let's see what happens. I need g prime of 2. So just kind of doodling over here. So g prime of 2 is f of 2. And that has been established in our previous work. G prime of x is f of x. And so f of 2 is on our graph. It is negative 4. So we're going to have negative 4 divided by 2, which is negative 2. All right, last one, part D. Ha, fun stuff. It's about to get crazy. All right. Find the average rate of change of g on the interval from negative 4 to 2. Just stop right there. You can keep reading if you want to, but you're going to earn some points just for answering that first question. So before we get all overwhelmed in the mean value theorem guarantee, okay. Find the average rate of change of g on the interval from negative 4 to 2. Sounds easy. G of 2 minus g of negative 4 over 2 minus negative 4 is going to give me, well, 6 in the denominator. There's the easy part. And over here on the side, just because I feel like it, I'm going to find out what g of 2 is, and that's the integral from 0 to 2 f of t dt, kind of a waste of time. We already know that's 0. We found that out in the previous problem and the one before that. G of negative 4 is 0 to negative 4 f of t dt. And we're going to figure that one out. That one's going to take a little bit more work. It might behoove you to change the sign of that and turn it around. Whoops, 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 whoops. White out. Put this in order from negative 4 to positive, no, negative 4 to 0, positive 0. There is no positive 0. F of t dt. And then we're going to figure out what this area is. So negative something. And here goes. Area from negative 4 to here. Let's see. How are we going to do this? Let's treat it like a triangle that is 2 wide and 6 high. So triangle, so 1/2 base times height plus, running out of room here. And then we'll treat this part like a trapezoid, or you could just count the squares in this case. And if we do a trapezoid, it'd be 1/2 height, which would be 2. So 1/2 height, which is 2, and then base 1 plus base 2, which will be 6 and 4. And we're going to have, let's see, 6 here and 10 here. So negative 16, and we have minus negative 16. Be careful with that. 16 over 6, which is 8/3. Okay, mission accomplished on the first sentence. We haven't even finished reading the problem yet, though. Let's keep reading. Does the mean value theorem, stop right there. In order for the mean value theorem to apply, we have to have continuity and integrability on different types of intervals, open and closed. So we need to have a function that is differentiable from negative 4 to 6, including, just on the open interval. Sorry, just going through that in my head. We have to have continuity from negative 4 to 6, including negative 4 and 6. Differentiability on the open interval from negative 4 to 6. And so we do have differentiability for sure, and that implies continuity. And here we go. We have continuity anyway, so we're good. We have what we need in terms of continuity. So here is the deal. Does the mean value theorem guarantee a value for which g prime of c is equal to the average rate of change? Justify your answer. Yes, it does. Let me launch into the explanation and you'll see why. So the mean value theorem applies, almost misspelled applies, there we go. That second P is larger than the first one. Applies because g of x is, okay, we need to have a couple conditions met. We need to have continuity. It's continuous on, it needs to be the closed interval, which really makes sense. Like, we have to have continuity from here to here in order to find the average rate of change anyway. So, continuous from negative 4 to 2, and is differentiable on the open interval from negative 4 to 2, put parentheses on that one. Okay, good, fantastic. So does the mean value theorem guarantee it? Yes, it does. So I'm going to just articulate a little bit more here. And so therefore, there is a C in the interval from negative 4 to 2 such that the derivative of g at that C value is equal to, I'm going to throw this in here, f of c, because then we're going way back to the very beginning, one of the first things we wrote in this, where we kind of broke it down and we said, well, the derivative of g is f. If you leave that out, will you get points? I'm going to say yes. I'll look at the scoring guidelines in a minute, but it doesn't hurt. It doesn't hurt to put that extra stuff in. Equals 8/3. There we go. So I am about to scroll through the scoring guidelines, and we're going to see what we did, see how we did, and we'll start back over at the very beginning. Here we go. Let's grade this thing in red. We got 1 point for A, just a point for A. Yep, we get a point for that. And as I read the scoring guidelines, they're really looking for where F is increasing, and they're also looking for this. So there we go. Did we miss it for that reason? No, but this part right here is much better. All right, part B, 1 point. Just all that was 1 point. We're about to get 3 points here. We're going to get a point for the product rule. Point earned. We are going to get a point for, oh, this is interesting. We get a point for either G of 3 or G prime of 3. So we got a point for G of 3 right here. We would have also earned the same point for getting G prime of 3. So we could have gotten it here or here. So either one of those would have gotten us a point. Fortunately for us, we got the whole thing, and there we go. We got a point for that. Okay, moving on to part C, where we're about to earn all our points here as well. Let's see. Oh, using L'Hopital's rule. La Hospital is what they called it, and they left a little hat off of their O, but whatever. I'm not going to criticize their lack of the understanding of the French language. So, using L'Hopital, if you did not write L'Hopital, I think you'll be okay. Yeah. Okay. We did need to demonstrate that the numerator equaled 0 and the denominator equaled 0, but you will lose that point if you show it as 0 over 0. So when I say L'Hopital, it wasn't the stating of L'Hopital, it was really this whole process right here. And then the final answer there we go. Right there. And now we scroll to part D. About to earn 2 more points. We get 8/3 as an answer, and there's one of them. And then the other one is going to be basically this. That's it.